Hello, welcome to the talk on Year 13 Applied Chapter 4, Moments, Section 4, Centre of Masses. So far, when we've done questions involving beams or anything like that, we've assumed that the beam has its mass uniformly distributed throughout its length, so that the centre of mass occurs in at the centre of the beam. There could be other questions where the beam or other object is non-uniform, and you might be asked to find out exactly where the centre of mass falls in that particular object. That's what we're going to look at in this video. Okay, so this is just what I've mentioned. Yeah, we normally assume your mass is equally distributed on the rod. The key thing to look for in a question is if it tells you that it's non-uniform, then you can't just assume that the centre of mass is going to be in the middle of the rod. Instead, you've got to solve to find that. Okay, quick question on that I pinched from the textbook. Could you pause me and have a go at that for me, please? Okay, as always with mechanics questions, the key is to draw your nice diagram showing all your forces on your diagram and all your distances as well. Okay, so right, so you've got the mass of the beam is 25 kilograms, so your force is 25 G. The complete length is 4 meters. Okay, on this one, it tells you where the centre of mass is. It just isn't in the centre of the beam. The main tools that you've got with this sort of question is either to resolve your forces vertically and horizontally, or to take moments about different places on the beam. On this particular question, they've taken moments about M, which was where it was pivoted, so they've taken moments about M here. So your moments going anti-clockwise is 25 G times by 2 meters. Plus you've also got the weight of the beam, another 25 G. This is 0.2 meters from M where you're taking your moments. In the opposite direction, your clockwise moments, we don't know where Sam is. We're trying to figure out where Sam must be for the beam to be balanced. So if you call the distance that Sam is as, what they call it? They've called it a distance they've defined X as the distance from A to where Sam is. So Sam's weight is 35 G. The full distance from here is 4 meters. This distance is 2 meters. So the distance from here to here is X less than 2 meters from where Tamsin is to the pivot at M. So the extra bit here is the full X less those 2. So that's where the X minus 2 comes from. Your only unknown in there is X, which gives you 3.57 meters. And we were asked to find the distance that Sam was from the point A, which is your 3.57 meters. Another question for you to try, actually an old A-level question. If you could have a go at this one, please. If you pause me, and then I will go through the answers with you. Okay, key thing first, make sure you've got your diagram in. Everything in your text must be included in your diagram there. So we've got all our distances that we had there. We've also got all our forces as well. So it's 4.5 kilograms, so a force of 4.5 G. You're told that you've got The magnitude of the reaction force at P is twice the magnitude of the reaction force at Q. So I've got 2x at P and only x at Q. Okay, so the way that they've done this first one, the magnitude of reaction force of the support at Q on the rod. Again, your tools are, you can resolve vertically, resolve horizontally, or you can take moments about some point on the beam. Here, they've resolved vertically. That's what your little arrow's for there. Your forces going up are your 2x plus your x. You've got 3x's going up. Your forces coming down is just the weight of the rod. So it's 4.5 G. You can solve that, and your only unknown is the x, which is 14.7 or 15 newtons. And for part B, the distance from A to G. So on part B, they've taken moments about A, so they've shown that as the M for taking moments and the thing that you're pivoting about inside the brackets. So they take moments about A. Then we've got clockwise moments. We've got force of 4.5 G, the distance from A to G. You've got force of 2x, a distance of 0.8. A force of x at a distance of, and the full rod's length is 3 meters, that's 0.6, so a distance of 2.4 meters. The only thing you don't know is the distance from A to G, so if you solve that, you should find that A to G is 1.3 meters. Okay, so that's the section done on non-uniform rods. Can you have a go at exercise 4D? Got to do 1 to 6, and you should really be looking at doing 7 and 8 as well. Thank you for listening.